Hey guys, and welcome back to another tricky A-Level Maths exam question. And in this question today, we're looking at proving the derivative of cos x is minus sin x using first principles. So this is quite a... Some students find it very easy to just memorise it and just use it like that. Some just prefer learning the few little steps that are important in the proof. But it's nothing too long as a proof. So let's have a look at starting it first. And what I've done is I've written down some important formula that you might need. This is in your formula books, don't worry about memorising it, but it's nothing too intense anyway. So this is the cos A plus or minus B, and they do say you can assume the formula for it. So that just means you can use it in your formula book without worrying about proving that as well. We're also given this, that as h tends to 0, sin h divided by h tends to 1, and cos h minus 1 divided by h tends to 0. So these are going to be very important, and we'll have a look at that in a second why. So the first thing we can do is write down what f of x is. So f of x, well, that's just what we're starting with. So that's cos x. So cos x. And then what we'll also do is write down f of x plus h. So f of x plus h, well, that's going to be cos, and then it's going to be x plus h again. So similar to above, but we have a plus h as well. Oops, I know it's a little bit scruffy, but I hope that's okay. So that's cos bracket x plus h, and then close the bracket like that. So that's the first bit. Now, because we're proving the derivative here, so we're using first principles. So again, the formula is given, but it's quite nice and easy to remember. So I'll write it down up here. What this starts off as, that'd be dy by dx. And then this is the same as now, so it's going to be f of x plus h, so f of x plus h minus f of x all divided by h. So if we do that and write down using what we've got, that's going to be cos x plus h minus cos of x, because this is your f of x, and this is all divided by h. What I should have done actually is written down the limit. So I'm going to write above, it should be a little bit close to the left, but the limit as h tends to 0 here. So that's what we're looking at. When the limit of h tends to 0, what is the limit of this? So that's the first line of working. Let's keep going with this. So again, the limit as h tends to 0. What we need to use now is we need to use this formula here, cos a plus or minus b. But we're using it here with cos x plus h. So because it's plus, we're going to do minus here. That's all that means. So because it's plus, it'd be minus. If it was minus, obviously, we'd use the minus again here. Sorry, the plus. So that's what that's just saying. Now, let's do this formula here, the compound angle formula. So, cos x plus h, well, this is cos a, cos b. So it's going to be cos x, cos h. So if we write that down, it's going to be quite long. Cos x cos h, like so. And then again, because it's plus here in the formula, that's what we're doing here, x plus h, we're going to use the minus. This is going to be minus sin a, sin b, so it's going to be sin x, sin h, minus sin x, sin x, sin h, like so. And then don't forget we have to solve off the original minus cos x that we had at the very beginning, minus cos x. So first thing to note as well, if I just put the division of h here, don't get confused with this cos of h here. Be very careful if you're doing further math, you might recognise this as, or you know, be very close to recognising this as a hyperbolic trig function as cosh, so be very careful for that. But if you don't do further maths, don't worry about that. So that's cos h. So now, what we need to do is take a look at the numerator here and see if there's any way we can pull out a factor here in the top. And what I notice is that I've got a cos x, cos h here, and I also have a cos x here. So what I'm going to do is I'm going to pull out this factor of cos here. So again, we're going to do the limit as h tends to 0, but I'm just going to write that as dot dot, just implying that we're using the same limit again. So I'll apply this cos x. So cos x. And then what we're going to do is times it by what we've pulled out. So we've pulled out a cos x, so that's going to be, so I'll do it in a big bracket, cos h, so cos x times cos h, like so. And then what do I have times cos x by to get minus cos x? Well, that's going to have to be minus 1, like so. And then we're going to have the minus sine x minus sine h at the end. And what I'd recommend is look at what they've told you. So they've told you that sine h divided by h tends to 1, and cos h minus 1 divided by h tends to 0. That's h tends to 0. So this is important, and they're giving you this to make this proof a lot easier. And notice we actually have now cos h minus 1 here, and we don't quite have this in sine h over h formula yet, or the expression that they give us here, but we can manipulate that one step further. What we can actually use is linearity here now. So remember, linearity, it's the same as when you're integrating. You can split this limit now as 2 limits. So what this is going to look like, so what I'm going to do is also play the cos x at the front. So this is going to be cos x. So cos x times the limit as h tends to 0 of this part of the expression now. So it's cos h minus 1 divided by h. So we're splitting up into 2 fractions as well. So we're using linearity by splitting up into 2 limits and 2 fractions. So it's going to be now cos h. So cos h minus 1 divided by h. So we're getting there now. We've got the cos h minus 1 divided by h. So that bit's done. Now can we get this part in the same expression here? And this is your clue. If you're not sure how to do it, just use this formula that they've given you, or this part of the expression that they want. So what we're going to do now is plug the sine x in front of the limit again, just like we did here. So this is minus sine x like so. And then again, the limit as h tends to 0 of sine h over h. Again, it's another fraction. So sine h over h. And then we have to look at what we know. We know that as h tends to 0, so that's what we're saying here. We're taking the limit as h tends to 0. Well, cos h minus 1 over h, as h tends to 0, that tends to 0 as well. So this is 0. And then we've got, well, that's 0 times cos x, but obviously anything times 0 is just 0. Then we've got minus sine x times the limit, as h tends to 0, of sine h over h, which we know tends to 1. So we've got minus sine x times 1. So this is 0 minus sine x, which is just clearly minus sine x. And there we have it. We have proved that the derivative of cos x is minus sine x using first principles. So there we have it. QE.